Hello everyone, welcome back. We're going to cover a very important topic today called running totals, so pay attention. First I'm going to give you a couple quizzes. So I'm going to give you a bunch of numbers and I want you to add them up for me. Okay, ready? 2, 4, 3, 9, 8, 6, 1, 5. So what did you come up with? I didn't actually do it in my head, so I don't know. But I probably know how you did it. What you probably did is you kept a running total in your head. So every time I'd say a new number, you would add that to the running total in your head. And then when I was done, you just gave me the running total. So that's the concept of a running total. So another example is I want you to tell me the maximum of these numbers. I'm going to give you a bunch of more numbers. 34, 21, 68. 111, 3, 410. What was the maximum? 410. So there you kept kind of a running total, sort of a running maximum. And every time I said a number, you said, well, this is bigger than the number that I already have. And if it wasn't, you ignored it. And if it was, you switched your running maximum to that number. So that's exactly the way you want to program a computer to do a number of algorithms, like adding up numbers, multiplying numbers, finding the maximum of a bunch of numbers, the minimum of a bunch of numbers, the average of a bunch of numbers. There are so many problems in computer science that are just like this running totals concept, so I decided to focus the video just on this. So we're going to learn two things. One, an easy thing, which is the word void, and this is when a method doesn't return anything. Remember how we put like int or double at the beginning of in a method header if it returned the data type it returned. If a method doesn't return anything, let's say it just shows something to the screen, we say the return type is void. That tells Java what to expect. And the second thing we're going to learn is a very unusual looking line of code, x equals x plus 1. Now remember, and you know in math this never is true actually, but remember the equal sign in Java is not the same in math. It's an assignment operator. So what it does is it evaluates the right-hand side. So whatever x is, let's say x was 4, it's going to evaluate the right-hand side first. So it's going to take 4 plus 1 and come up with 5. And then it's going to take whatever it comes up with and stick it in the left-hand side. So it's going to put it back into x. It's going to take x from 4 to 5, basically. Another example is total equals total plus x. So what this again will do, when you see an equal sign, don't think equals. Think, move over to the right-hand side. Evaluate the expression. So what is total? What is x? Add them together to come up with a number. And then equals means it puts that expression, the value of the expression, into this variable. So the variable can actually be on both sides of the equal sign. And this is very common in a running total algorithm like you'll see in a moment. Okay, so let's go to the computer. We're going to write, I think, 4 or 5 of these different running total algorithms so you get the hang of it, and then we'll recap. Okay, we're going to start with writing a method called show numbers. This won't be a running total, but it's kind of good practice to get ourself in the mood to do a running total. What this method will do, it'll take one parameter, let's say an integer, let's say we pass it 20, and it'll show the numbers from 0 up until that number. That's it. Okay, so let's go write that. All these methods will be public static for now. Again, I'll teach you about that in the future. This particular method doesn't return anything. It just shows things to the screen. So here's where we would ordinarily put what the method returns, but we're going to use the word void because the method doesn't return anything. And the next is the name of the method. And then in parentheses are the parameters. There's one parameter, an integer, and we will call it x. Okay, so x will be the maximum number that we want to print. To do something like we have in the spec, you would do a for loop starting at 0 and ending at the parameter, ending at the number that was passed. So if you recall, a for loop is the word for, and then in the parentheses there are 3 parts. Something that initializes a loop control variable, which is usually I. A lot of people use I for that. So we'll start at 0. a continuation condition. So we'll keep going while I is less than or equal to x. Okay. So this is a little different than what we did before. So instead of a hard-coded number, like 20 or whatever, we're just going to look at the value of this parameter and stop then, or keep going until we hit it. And the third part is what to do with I after each iteration of the loop, and we are going to increment it by 1, which is very typical. Okay, so within the loop, all we're going to do is actually show I. That's what would do the trick. Okay, so let's run it, see if that works. Run show numbers, and I'm going to do it to 18, let's say. And voila, we have from 0 to 18. Okay, so now we're going to do our first running total, and it's a method called sum up to. And it's going to take one parameter, an integer, and let's say I pass a 10. It's basically going to add all the numbers from 0 to 10. So 0 plus 1 plus 2 plus 3 plus dot 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 all the way up to 10, which I know is 55. So again, public static. This one does return something. It's going to return the answer, which is an integer. Then we have the method name, and then we have the parameter. We'll call this x as well. Okay, so x is the maximum number we're going to add in our little sequence here. The way to do a running total is you initialize the total variable before the loop even starts. So pick a name for it. We'll call it total. It's an integer. You're adding up integers, which keeps it an integer. So we'll initialize it to 0. 0 is sort of the identity for addition. Good place to start. And then at the end, I'm jumping to the end, you're going to return that, that running total. Okay? So that's how I set it up. Initialize the variable, give it a couple spaces, and then do a return. Okay, and then in the middle we're going to do our for loop where we loop through each of the numbers and add them onto total as a running total. So for, this is going to be just like the for loop above. That's why I did it for you. So we start with 0. You can start with 1 even. We will keep going while I is less than x. In other words, when it gets greater than x, it'll stop. And we will have I go up by 1. And now what we will do is the line of code you saw on the board, actually not quite on the board, what we're going to do is we're going to keep adding I on top of total. That's what total plus I, the expression will do. It'll take total, add I to it, and then put its answer back into total. So this is exactly how to do a running total. So what we're going to do is we're going to watch it work just so you can really understand it by putting a breakpoint. So sum up to, let's do 10. Okay, you can see at our breakpoint x is 10. So the reason x is 10 is because I called it with a parameter of 10. Okay, so that's the value of x. Total should be 0 after that line of code. It is. I should be 1 the first time through the loop, which it is. So what this line of code is going to take total, which is at 0, add I to it, which is 1, and then after this line of code, total should be 1. And it is. Next time through the loop, I is 2, so it's going to take total, 1, plus I, 2, which is 3, and then put that into total. So after this line of code, total should be 3. And it is. And then it just keeps going. This should be 6, and then 10, and then 15, 21, etc. What you can do if you're tired of watching the loop, you can put a stop sign down here, which means when I hit that, stop. And then you can hit continue, which means I know you're breaking through the code, but I'm tired of breaking through the code, so just go to the next stop sign, really. So you can see total equals 55 at the end of the loop, which is the exact right answer. Okay? So that is a running total, and that worked out just fine. So we'll do one more, which is factorial. So this is a multiplication, If you recall, factorial of 6, let's say, is 6 times 5 times 4 times 3 times 2 times 1. So that's a really useful math concept, especially in probability. So we'll do a running total for that. So instead of adding numbers, we're going to be multiplying on top of a running total. So let's do it. Public static. This is going to return an integer. The method name is factorial, and it's going to take one argument, an integer as well. Okay, so remember what I said. Pick a name for the variable and initialize it. So let's do total again. You need to initialize this to 1 because a 0 multiplied by anything still stays at 0. So 1 is basically the identity number for multiplication. So you start with 1. I learned that by having a little bug earlier today. And then at the end, return total. Like I said, that's the best way to do a running total is do the beginning and the end, and then we'll write our for loop. Now just to make this a little bit easier to understand, most people do factorials counting backwards. So factorial of 6, they do 6 times 5 times 4 times 3. So we're going to count backward as well. And you can do this with a for loop. So instead of I starting at 0, we're going to start I at x. Okay, so I will start at 6 in our example the first time through the loop. We will keep going while I is greater than 0. So when it hits 0, we want the loop to stop. And lastly, each time after the loop is done, we want I to get 1 smaller. So you do this, you may have guessed this, with an I minus minus. Okay, so that's how you go through a loop backward, basically. All right, now what we're going to do is total equals total times I. And it is as easy as that. So again, sometimes helpful to watch it. Actually, I should say it's always helpful to watch it once. So let's do the factorial of 6. So you can see x was 6, that's what got passed in. Total is 1. First time through the loop, I should be 6, and it is 6. You can see it there. So total times I is 1 times 6. That's 6. That gets put into total. That worked. Second time through the loop, I should be 5, and it is. It's because the I minus minus goes next. So total times I is 6 times 5, which is 30, and that gets put into total. Okay. I'll just step through the whole thing. Okay, so the total is 720, which is the right answer. So we'll just see the end. Total is 720. Okay, so that was basically our last running total. So let's go to the board, and I will recap. Okay, let's do a quick recap. So we learned void. That's what you put in a method header when it doesn't return anything. We learned how to go through a loop backward. Basically, take the loop variable like I, and you do I minus minus, and then it gets 1 smaller each time through. And then the basic pattern of doing a running total type of algorithm. You pick a variable and you initialize it before the loop starts, like a total, setting it to 0. Then you jump to the bottom and you return that total at the end of your method. So I usually write that line, then that line. And then you write your for loop, and or whatever kind of loop you would have to sort of build that total. And you're usually going to have a line of code that looks like this. Total equals total plus I. So you have the same variable on either side, which you should not panic just because it's an equal sign. Essentially what Java doesn't consider this equal. It's basically assignment. So it evaluates whatever's on the right and then puts that into what's on the left. So a line of code like this keeps piling I, the values of I, on top of total, basically. So that's it. Hope that was helpful, and talk to you next time.